All right. Let's consider another ODE. But just for a change, let's start with a physics problem. The most classical, perhaps, of all physics problems, called the harmonic oscillator. Very important in this case to know where the problem came from. It will help you guess the solution. Also, it's such an important problem and it's such a metaphor for everything else. It's everything having to do with waves and music, sound, music, and all of that. So, we have a spring of stiffness K. We're going to use Hooke's law. And a mass attached to it of mass M, a mass of mass M. How does that sound? And it's at equilibrium right here. And we'll call this x equals 0. So x is positive here, x is negative here. And of course, this is governed by Newton's equation. Newton's second law, F equals ma. Should I write it down? I mean, it's always a pleasure to write F equals ma. F equals ma. Okay. So we're already beginning to see a second derivative. Are you guys with me? Do you see a second derivative? A is a second derivative. I think at some point I'll give you a spiel titled An Ode to Second Derivative. The best of all of the derivatives. The second derivative that drives the world, that's responsible for life, that's responsible for movement. Movement is second derivative. Sometimes it appears as a derivative with respect to time. Sometimes it appears as a derivative with respect to x. But in neither case, it just seems like the second derivative is needed for movement and therefore life. Okay, so F, according to Hooke's law, is minus kx. Because if you pull the string in the positive direction, the force will act in the opposite direction. The force will bring you back. It's a restoring force. So minus kx equals m times the second derivative of x, and they're both with respect to time. I could sneak it in here. Okay? So, now I will add one other element. I will pretend that somebody is on top of this string doing what it does. There's also someone externally applying a force. So maybe this is a magnet and it's an alternating magnetic field. But whatever it is, I want to add an additional external force. It's external to the system. So the spring is part of the system, and this force is an external influence. Why? Because I want to have an inhomogeneous equation. Does that make sense? This is a homogeneous equation. I want to have an inhomogeneous equation. So we're inspired by this, but the way I'll write it, I'll go back to u, and we'll have u double prime plus 9u. So I'll pretend this is 9, because I want to have a specific equation. I'm going real fast from being a physicist to being a mathematician. Equals, and somebody's driving it, let's say 2 sine of 4t. Why not? And also, this is an interesting problem. And it will be particularly interesting and will have particularly important physics applications if instead of a 4 here, I picked yes, 3. Stole my thunder. Yes. That comment did not resonate with me at all. So, as a mathematician, you should look at this equation, and your first instinct should be it's absolutely no different from the other equation we just did. Do you agree? Linear equation, check. Constant coefficients, check. Inhomogeneous, check. All of the ingredients are exactly the same. Except you know that exponentials won't work. Because you know what the system does. If you believe in correlation between math and physics, not correlation, but the fact that solutions to mathematical equations describe the natural world, and we all have that delusion. We're taught that delusion in high school and college and grad school and beyond. Then you would say that it's impossible that we would have exponential solutions here because we expect an oscillation. Interesting. So what will go wrong? But for now, the part that's not negotiable is the fact that the solution will look like a particular solution plus the null space. And instead of writing the null space, I will actually write C1 N1 plus C2 N2. Because I already know a little bit more. Second order operator means two-dimensional null space. And all two-dimensional null spaces look like this. And once again, I can think of it in both from the physics point of view and the treasure hunt point of view. I will need two initial conditions here. Because when you set the system in motion, you have two control parameters. Where you let it go, right? You can pull the string and just let it go. Or you can, at a certain location, sort of, launch it in a particular direction. So give it both displacement and velocity, or position and speed. So this problem, being Newton's equation, dictates that we need two conditions. And this system, being second order, and the treasure hunt logic, dictates that it has two initial conditions. And this linear algebra perspective on it dictates that we have two initial conditions. Everything's matching. And I'm reiterating all of these things because there will be a situation where if you were only thinking calculus, you would miss that something's amiss. And you don't want to miss when something's amiss. You would be remiss to miss when something's amiss. Okay, once again, shall we start with a particular solution? Can we kind of guess? I think it's not so hard to guess that it should be proportional to sine 4t. You guys agree? If there was a middle term with a u prime, then maybe not, because then we would pick up a cosine. But with the u prime term missing, this will give minus 16 sine t. And this will give 9 sine t. Too bad I can't add them and get 25. I have to subtract them. And so I get minus 16 plus 9. Help me here. Minus 7? Minus 7. And I need 2. So 2 minus 2 sevenths. U equals minus 2 sevenths sine of 4t. And I did it all in my head on purpose. I feel that in many situations, if you take your mind off the problem and just start writing out the arithmetic, you will lose the big picture. And I want you to always keep the big picture in mind. And doing things in your head without taking your eye and your mind off the problem sometimes saves time and saves errors because you can keep your eye on the ball. So did I do it right, by the way? Yeah, everybody agrees? So I recommend that on the exams, everything, you do it in your head. And then if you feel a little bit uncertain, you just plug it back in. And you get, oh, look, I'm getting minus 32 sevenths plus 18 sevenths. Hey, that's 2, because it's 14 sevenths. Existential crisis, wow. You might want to review your political system. Okay, now, null space. So let's jump straight to that quadratic equation, which will be lambda squared that determines the exponent. Lambda squared plus 9 equals 0. Okay? And that's where you realize why the exponents fail. Excuse me, why exponential solutions like we might have expected will not appear in this case, thankfully, because we know from physics that they do not belong. And that's because both this system, we're in the real world or complex world? Let's pretend we're in the real world. Let's pretend we're in the real world. This system has no solutions. And so you have to look for other members of the null space. The exponents, like we guessed before, will not work. The method breaks down. Later on, I'll tell you what will happen later on. But you know what will happen later on. Complex numbers, and then the order is restored. But it took someone like Euler to restore the order. So let's, for the time being, pretend that we're living in a world without Euler. And what a sad world it is. So for our guess, let me write down the homogenized version of the equation to help us with our guessing. So no go. Homogenized version of the equation is u double prime. Because now I will put it in words. And it's amazing how often when you just put something in words, the solution presents itself to you. It sort of speaks back. If you speak to the equation, it'll speak back to you. You're looking for a function whose second derivative is minus 9 times the function itself. If I skip the 9 part, second derivative is minus the function itself. Sines and cosines, you're used to that, right? Hey, 2, we just got 2 functions. That's good, that's exactly how many we're looking for. And what does this 9 do? It just makes it 3t. So it's cosine of 3t. Yes? I'm just curious. Between the sine and the cosine, do you guys have favorites? Who prefers the cosine? Who prefers the sine? Who has no preference? Okay. 30, 33, 33, 33. So this is the general solution. This is the general solution in this case. And I don't know what else I can add to this problem. I'm just going to look at my watch and see, oh, we have plenty more time. So in real life, this problem would come with initial conditions. U at the initial moment and the velocity at the initial moment. That's the typical setup. And I trust that because you saw the previous example, this example will continue the same way. And you will be able to determine C1 and C2, and therefore find the unique solution to the ODE system with which you were presented.